For this example, we've been asked to calculate the limit as x tends to 0 of sine x all divided by x. So the first thing we need to do is substitute in x equals 0 and see what happens with our function. So when x equals 0, sine of 0 over 0 simply becomes 0 over 0, which we don't know how to deal with. So we need to find a way of taking this limit, and to do so we're going to use L'Hopital's rule because we have 0 over 0. Now L'Hopital's rule tells us to differentiate the numerator, differentiate the denominator, and take the limit as x goes to 0 of this new function. So the derivative of sine x is equal to cos x, and the derivative of x is equal to 1. Therefore, we have the limit as x goes to 0 of sine x over x is equal to the limit as x goes to 0 of cos x over 1. Now, the limit of cos x over 1 is cos of 0 over 1. And cos of 0 is 1, so we have 1 over 1, which is 1. Therefore we can say that the limit as x tends to 0 of sine x over x is equal to 1. Now, as an aside, in a later section we will see that sine x can be written as x minus x cubed over 3 factorial plus x to the 5 over 5 factorial minus x to the 7 over 7 factorial, etc. And we can use this result, this is known as the Maclaurin series for sine x, we can use this result to also calculate our limit. The limit as x tends to 0 of sine x over x can be written as the limit as x tends to 0 of x minus x cubed over 3 factorial plus x to the 5 over 5 factorial all divided by x. Now this x can divide into everything, so it divides here to give us 1, here to leave us with an x squared, here to leave us with an x4, etc. So we can see that this becomes a limit as x tends to 0 of 1 minus x squared over 3 factorial plus x to the 4 over 5 factorial. And now as we take the limit as x tends to 0, this term will be 0, this one will be 0, all subsequent terms will be 0, leaving us with just 1. So using this alternate method, which we'll see in a later chapter, we can also take the limit of sine x over x and still get 1.